Okay, let's talk about the color-based image segmentation using clustering techniques. Firstly, let's talk about clustering. Clustering is a technique mainly focused on aligning the data points to several sets according to meaningful feature. And clustering is different from classification. The difference here is about the predefined sets. When we do classification, we know that those classes we need to assign the points to. But when we do clustering, we have no idea about that. All the sets are created during the process of clustering. A clustering can support the image segmentation. What we talk here are two basic clustering algorithms, the k-means algorithm and the fuzzy c-means algorithms. Of course, there are other clustering algorithms such as EM algorithms, and fuzzy kc algorithms, and so on. But the k-means and the fuzzy c-means are the basic ones. And other algorithms, a lot of algorithms just improved these two ideas, and they improve the performance and support the specific applications. But the k-means and the fuzzy c-means can support the image segmentation. Although the performance may be not that good, but they can do that. The image segmentation can be divided into several categories. What we talk here is the clustering based segmentation. Now, of course, there are many other categories such as region-based segmentation, edge-based segmentation, and so on. Image segmentation is widely used, and they have many applications. Of course, what we familiar is about the face recognition and the data compression. And okay, let's go on with k-means algorithms. K-means clustering is a well-known approach and is very easy to operate. And so the advantage is very apparent. Its operation don't need much time. The complexity is relatively low, not like some developed algorithms based on k-means, whose complexity is very much. Running those algorithms may need much time. But as the basic idea, algorithms, k-means of course have its limitations. The first one is when we operate k-means, we need to the most important things is those centers we initial and evaluate. When we the goal is to get the optimistic position of those centers, but using k-means, those centers may sometimes converge to local minima, which is not the optimistic one, but they are stable. So at that time we cannot get what we want. The second one is k-means algorithm may neglect the local connection, which means that the k-means algorithms just use the distance to evaluate the optimistic solution. When doing the image segmentation or some other clusterings, the local connection about other features may be neglected, or we can say that using the k-means, we can't support that requirement. Okay, the main idea of the k-means algorithms is to optimize the partitioning decisions based on a user-defined initial set of clusters, which is we discussed before that we should initial those centers before we do k-means use k-means algorithms. And this is the flow chart. And first we start initial the centers and calculating the point, the whole points, all the points, the distance of all the points between all the points to those centers. This distance is the variable what we need to evaluate. The next is grouping based on minimum distance, which means for a particular center, all the points that near this center, we should add the distance, add those distance, and the sum of this distance, we want to get the minimum value, which means the position of those centers may converge. And if when the centers are stable, which means the algorithm that the solution is what we get, and finally what we get. Okay, these are several equations about the k-means algorithm. The first one is the distance. The second one is the position of center. The third one is the threshold, which is what we when we find the solution. The threshold of two clusters can be calculated by this equation. Okay, next we talk about the fuzzy c-means algorithms. Like the k-means algorithms is also a simple, well-known, widely used algorithms. The main idea is that it first separates the data points into fuzzy sets, and then use the distance, just like the k-means, to evaluate the optimistic solution. And of course, fuzzy c-means have two shortcomings. The first one is like k-means, the number of clusters needs to be specified in advance. Without the number of clusters, fuzzy c-means cannot work. But the second one is not what we talk here. The fuzzy c-means is limited in several spherical clusters. If we do the image in place segmentation or some other applications of other kind of clusters, the fuzzy c-means may not work. And of course, due to these two shortcomings, there are many improvements to fuzzy c-means, which are, for example, the UFC, PCM, and so on. And now we come to the simulation. What we talk the k-means algorithm, the fuzzy c-means algorithms, and let's see how they work to support the image segmentation. As we said, they are not very sufficient, not very efficient, but they are easy to operate. Also, first, let's see the k-means algorithms to support the image segmentation. This is the picture. The left one is before the segmentation, and the right one is after the image after segmentation. And what we see here is that the performance of k-means is not that good, and there are many errors after the segmentation. Uh, After the simulation, the k-means, the accuracy of k-means is basically about more than 75%. So what we see here is what we know here is that it has much errors. I know, and also let me see the fuzzy c-means algorithms. Here's the fuzzy c-means algorithms to do the image segmentations. The performance seems better than the k-means, but let me see, it also has some errors about the edge compared to the original picture. Okay, let's see the application. The clustering support the image segmentation can be used for many other areas. One of those important areas is medical imaging, which is used, of course, used in the hospital, and here and for the RMI or some other technical photos. Okay, here we can conclude that clustering can support the image segmentations for many kind of applications, and especially for the important ones. But what we talk here are the basic ideas of clustering. They are easy to operate, but the performance may not that good. So what we will do now is just improve them and overcome those shortcomings, and at that time the algorithms may better support the image segmentation and also other applications in other related areas. Okay, that's all. Thank you.